Yo, dudes, we are checking out the second part of trig equations. It's out of 11A if you're interested in looking there. Before we jump into that, let's just look at solving for x or something like this. Solving for x really means when does this y function hit the x-axis, and you could look at a graph and find that it happens there or there. If they were to ask you something like that, you could solve for, you could move the 3 and get 0 on that side and then solve in the same way, and you could get it algebraically at 1 and -1. Or you could graph this half as y equals 3, that's this, and you could graph the other half as y equals -x squared plus 4, and that's this part. And you could ask your calculator where the intersections are, and it looks like they happen at there and there at 2, 3. Sorry, that's halfway between there. That's 1. Sorry, plus and minus 1 and 3. They should both equal 3 because we want this to equal 3. Where does that happen? At 1 and -1. Cool, so we can use a graph to find that. We can do the same sort of thing with trig equations. And sometimes they give you a graph like this, and they say, well, solve for when cosine of x is 0.4. If they've given you a graph, and we'll see how to graph a little bit more specifically how to transform the functions. But if they've given you a graph, you can say, all right, well, when does this equal 0.4? And you can draw a line. Here's about halfway, so a little below that is 0.4. And you can see where that happens. It happens here and here and here. If you're more specific, it happens here, and so you get like 1.2 out by looking at the graph, or 5 point something out, that's this part, or 7.4. Great, we've solved it, nice, by looking at the graph. Thanks, graph. You don't always have a graph, so sometimes you have to do it yourself. So grab your calculator, turn it on. I'm going to math magically put it in here. Whoa, did you see that? It's pretty exciting. We're going to ask your calculator to do this for you. So I'm going to plug in sine of x for one of my y values. So sine of x, make sure you're in radians. And for the other one, I'm going to put in 0.3, and we're going to graph it. Because of this graph, I know that we're going to go from 0 to 15 in the x, so I'm going to set my window to that. I might do -1 just so I can see the whole thing, and up to 15. And then my y should go from something like -1. So I'm going to put -1.5 so I can see the maximum and minimum. And then let's graph it. Ooh. Right. So it does something like this for you. There's the line, and so we should have several solutions. 1, 2, 3, 4, 5, and it doesn't quite get there in the end. So let's figure out how to ask your calculator for it. Well, you'd say second calculate, and you'd ask for an intersection. So either jot down to 5 or push the number 5, and you're going to have to do this 5 times. 1, 2, 3, 4, 5. But up and down jumps between the two lines, and back and forth moves along the line that it's on. So if we're trying to find this intersection, you get close, say enter, it jumps to the other one, say enter, guess, enter, bing, and there's 6.5, right? So this one is 6.58. Cool, find that one, find that one, find that one, find that one. A little tedious, but yeah, you can do it. And so there's the 6.6, and there's the other 4. Neat. All right, so we can do the same thing even if they're uglier pieces, right? If this really should be on a calc component, and so you could say, let's let this be y equals y1, and let this be y2. There's a graph, but just so you can see where it comes from and what to be careful about, you can say 2 sine of x, close your parentheses, minus cosine of x. And then on your next line, say 4 minus x. This is between 0 and 2 pi, so in your window, say, I'm going to say negative pi still, and I want to go to 2 pi. And let's scale by pi halves. It means there's a slash every pi halves. And then for the y, you sort of have to guess. I'd maybe go 10 and 10, but here, because I can see it over there, I'm going to go negative 4 and 4. And there's our beautiful graph of the 2 sine x minus cosine x, wobbly looking bit, and there's the linear green part. And then you just find the two solutions using tech. You'd say second calc and ask for the intersection, get close, right? 1.8, that's this piece. So 1.8 and 2.18. They're only asking for x, so we only really need the 1.8. And the other one is this one that they found, which is 3.3. And I think
Dude, you missed one down there.
Oh, I missed one. I told you. Why didn't you say something? That one, it also is there, right? And so you'd have to find 1, 2, 3. Tricky buggers. All right. If you want to practice this one, it's the same sort of thing. Here's the solutions. Bing, 1, 2, 3, 4. And great. So now, sometimes we'll have to do this not on a calculator, and so we'll let Bessie be at ease here. And we need to solve this. Well, you can do this with a unit circle. You can say, I want to take this piece, this original equation, solve for the sine of x. So if you do that, you get sine is half. And then see how many of those you run into as you walk between 0 and pi. So I know that sine of half, that happens at 30-degree angles, right? Since it's positive, we didn't take the square root, it's positive, so it happens also over here at, ooh, fancy. This is 30, this should also be 30, so this is pi sixth, this should also be pi sixth, so this is 6th pi sixths minus 1 pi sixth gives you 5 pi sixths. Fine, so it happens here and here, and as you go all the way around, I only see it once, twice, so, and we have to stop counting at pi, right? That's what this piece is about. So we're done, we get 2 solutions, right? You guys have done something like that before. We're gonna start messing with the range, so like this. Same sort of idea. Let's take all of this, actually, let's move you over G, you are not necessary. So if you solve for this, right, we're trying to find x, if you move things over, you get cosine of x is a half. Not a problem. Where does that happen? Well, it happens here at 60 degrees, otherwise known as pi thirds, and it also happens over here at 2 pi thirds. Pi thirds is is 2 sets of 30 degrees. So here's another 30, here's another 30, so this one is another 60 degrees. So there's my 2 sets, fine. Let's get rid of those. They have the same cosine, cha-cha, no they don't, half. So I guess that is incorrect. Why didn't you say something? Their cosines are down here. Cosine's positive, so they have to be here and here. So pi thirds. Call it negative pi thirds for now. Fine, 60 degrees, 60 degrees. So this happens in these 2 spots, and we're just going to count them up as we go from 0 to 4 pi. 4 pi is 2 spins. Since we're only going positive from 0, I'm going to rename this not as pi thirds, but as a positive value. This would be, if we went all the right way around, this is 2 pi, otherwise known as 6 pi thirds. So this should be 5 pi thirds. All right. So here we go. We're starting to spin. We hit this once. So one solution is pi thirds. We keep going, keep going, keep going. We hit it again. Another solution is 5 pi thirds. We're back at our origin, but we're at 2 pi, so we have to go another full rotation. So keep going, keep going. We hit this again. Since we've subtended a full rotation, we've gone 6 pi thirds plus another pi thirds. Now we're at 7 pi thirds. And then we keep going around and we hit this one more time. You could either count up the pi thirds, so 6 pi thirds, 7 pi thirds, 8 pi thirds, 9 pi thirds, 10, 11 pi thirds, 11 pi thirds. That's one way to figure out 11 pi thirds. Or you know all the way around 2 times is 4 pi, which if you're talking about thirds is 12 pi thirds, right? 12 divided by 3 is the 4. And you back up 1 to get to that 11 pi thirds. So that's another way to get there. And so I think those are our 4 solutions. Voila. Great. Moving on. All right, shake it off. Maybe get up, stand up. Fun if you guys did that in class. Started shadow boxing. Sometimes we have to change the interval. This gets messed with when you have something inside the sign with the variable. So this is kind of how it looks. It's a little odd at first. Maybe you've seen it. We had 2 or 3 questions like that in the last review. But here comes. I know that y equals sine of 2x. I want to find the zeros of this. Fine. Apparently, we can't use a calculator. So, I don't like working with the sign of something in here. So, I'm going to change it around so it's prettier, right? So I'm going to let theta be 2x. So instead of calling this y equals sine of x, I'm going to call it y equals sine of theta, just because I like to avoid my problems. Great. They didn't ask for the equation, they asked for the zeros, so I want that to be 0. Okay. So this is not a big deal. When is the sine of theta 0? Sine is the vertical component, so when is the sine of theta 0? It happens like here or here, roughly. The thing is, we don't know how far we're spinning. X is a value, right? We're not spinning x, right? We're not just going from there to there because we're talking about the sine of theta. And theta isn't x. Right? Theta is 2x. So think about this piece, if that doesn't jive with you yet. Think about this theta, right? This piece. The smallest thing that we could put in for x is 0, right? Because of this restriction on x. So if you put 0 in here, the smallest thing you'd get for theta would be also 0. 2 times 0 is 0. So theta is going to be bigger than 0 because of that. So now think about what's the biggest thing that x could be. Well, biggest thing is 180. So if you plug 180 into there, what's the biggest thing that will come out for theta? Well, it's 2 times 180, so it's 360. We have a new trig interval. We have a new angle interval because of this value inside with the x, the variable. So we're not just going between 0 and pi, or 180. We're going between 0 and 360. We're counting all the pieces all the way around, and it's inclusive of 0 and 360. Okay, so once you have this, you're just doing the spins and figuring out where sine of theta is 0. So it happens, at 0. So this is true. So our thetas are, one of our thetas is 0. I'm going to call it theta 1 is here. Another time that the sine is 0, means it's 0 above the axis, is when, I'm going to call it theta 2, when we're at pi. I guess I should probably call it 180 since they're talking about 180. So 180, and there's another one, our third angle that this works for, when we get back to 360, because they're inclusive, right? So 360. All right, great. We solved it. Only kind of, right? Because we're not interested in theta, we're interested in x, and theta is 2x. So you could say, well, really, theta is 2x, so 2x equals 0. And 2x equals 180, and 2x equals 360. And if you divide, you get x is still 0, x is 90, and x is 180. And those solutions will work for this. When you put 0 in, you get 2 times 0, and that sine of 0 is 0. Same with 90. When you put 90 in there, you get 180, and the sine of 180 is 0. And 180 times 2 is 360, and it works there as well. Cool, so I think that's what our solution should be here. Okay, so let's try that with a little bit deeper into the ugly spectrum. I know people like that. That's mean. That's mean. Never mind. So we've got this mess. We've got to solve for x. Same sort of thing. Here's our interval for the x's, but they're not our interval for what cosine could possibly be. Since we like avoiding our problems, let's let theta be x minus 2 pi thirds. Let's just get everything in there and simplify it. So therefore, this really is cosine of theta equals a half. Well, that's fine. I can solve for that, right? Whereas the cosine of half, it's positive, so it's there and there. Just like last time that I screwed up. Okay, it happens at those sites. The problem is this piece is going to change. Our interval is going to change because I'm not using x, I'm using theta, and theta is a combination of x and some other garbage. So what we've got to do from there is think about this. I want to see theta's interval. So the smallest thing that I could put in for x is negative 2 pi. So the smallest thing that will come out of there and be theta, the smallest theta you could have, is negative 2 pi minus 2 pi thirds. If you'd like to clean that up, be my guest, but it's not necessary to find the location. Okay, so that's the lower limit on theta based on the lower limit of x. If we do the same thing for the upper limit of theta, what's the biggest thing you could put into x? Well, it's 2 pi. So if you put that in there, the biggest thing that will come out, or here, the biggest thing that will come out for theta is 2 pi minus 2 pi thirds. If you think about 2 pi minus 2 pi thirds, this is 2 pi, here's 1 pi thirds. If you subtract another one, you're at 2 pi thirds, you're here. So this site is 2 pi minus 2 pi thirds. If you're looking for this site, you could say negative 2 pi is going backwards one whole rotation, and then going the same direction backwards, another 2 pi. You're in the same spot. So this is both 2 pi minus 2 pi thirds and negative 2 pi minus 2 pi thirds. Okay, so that's just our limit of what we're going to count to. Okay, this really doesn't need to be cleaned up that much. So let's look from 0 up to this solution. So basically, it's just from here to here, right? 0 to 2 pi minus 2 pi thirds. And as we go through that, we only hit one of these sites, this one or this one. We only hit it once, right there. It's at pi thirds. So one of our angles, I'm going to call it theta 1, is pi thirds. That's all of them on the positive side. On the negative side, if we go backwards, we're going to have to go backwards one full spin, that's 2 pi, and then minus 2 pi thirds more. So then we intersect here, 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 and here again. So the first one is going to be negative theta 2 is going to be negative pi thirds here at negative 2 pi thirds, right? We don't have to call it a positive value because we're going backwards, right? That's what this is about. And then we hit, here's 2 pi thirds, 3 pi thirds, 4 pi thirds, whoa, sorry, 1 pi thirds, 2 pi thirds, 3 pi thirds, 4 pi thirds, 5 pi thirds. So this is going to be theta 3 is negative 5 pi thirds. And the last one, 5 pi thirds, 6 pi thirds, negative 7 pi thirds. It's negative 7 pi thirds.
Could you click any slower?
Okay, so those are all our locations for theta. So we're kind of done with this piece for a second. Yeah. The problem is that it's not theta we're looking for, but x. And so we're going to replace our theta with this, right? We're going to say, oh, really, this is x minus 2 pi thirds equals pi thirds. So if you add 2 pi thirds to pi thirds, you get x is 2 pi thirds. Pi thirds plus another 2 pi thirds is 3 pi thirds. 3 pi thirds, otherwise known as just pi. Here we're doing the same thing. X minus 2 pi thirds should equal negative pi thirds. So negative pi thirds. Sorry, this shouldn't be over there. So pi thirds. Add 2 pi thirds to both sides. This is negative pi thirds plus 2 pi thirds. So x should just be regular pi thirds. 1 pi third, yeah. Oh, I copied the wrong thing. Write it again. This is x minus 2 pi thirds equals negative 5 pi thirds. So you'd add 2 pi thirds to both sides and you'd get negative 3 pi thirds, which is just negative pi. And this last part is 2 pi thirds equals negative 7 pi thirds. So add 2 pi thirds to both sides and you get 5 pi thirds, negative 5 pi thirds. All right, let's try that. Yeah, there you go. So there's negative 5 pi thirds, there's negative pi, there's pi thirds, and there's pi. Oh. Okay, let's try one more just to make sure you're on board. This is root 2 cosine of something plus 1. Let's take this and solve it for just the cosine. So this turns into the cosine of this mess, 3 pi fourths. Root 2 plus 1 equals 0. If you subtract the 1 and divide by 2, you get cosine of that mess equals negative 1 over root 2, which is negative root 2 over 2. We're used to seeing it that way. So really, like, I don't want to see all this junk. Let's let theta for the time being equal x minus 3 pi fourths. And then we can simplify what we are seeing for now and let this be negative root 2 over 2. Okay, so there's theta. That I can do. I know that this happens when the cosine is negative root 2 over 2. That happens at the 45s. So one happens there and one happens there. They're both negative, so they're both that half. Fine. This one we can call 1, 2, 3 pi fourths. 3 pi fourths. And this is 4 pi fourths, 5 pi fourths. 5 pi fourths. Okay, great. So that's neat. So I'm trying to basically solve that equation, but my interval changes because the guts here has a different minimum and maximum based on x's minimum and maximum. So theta at the smallest is when x is its minimum. You throw that in there, you get 0 minus 3 pi fourths. So minus 3 pi fourths is theta's minimum, the guts, the minimum of the guts. At the maximum, theta is when x is at its maximum, so throw that in there. That's pi sixths minus 3 pi fourths. You can clean that up, but we're really just looking for a location in space. So negative 3 pi fourths is starting at 0 and working backwards. 1 pi fourths, 2 pi fourths, 3 pi fourths. So this spot is negative 3 pi fourths. And 6 pi is 3 spins around. 1, 2, 3. And then back off 3 pi fourths. It's in the same spot. So this is also the site of 6 pi minus 3 pi fourths. Okay, that's just our beginning and end site. It happens, it happens to coincide with the locations where cosine of theta is negative root 2 over 2. Okay, so let's take that idea and let's start counting. All right, so we're going to start at negative 3 pi fourths. It's inclusive. It's less than or equal to. So we're going to start at this value and include this the first time we hit it. We're already at negative 3 pi fourths. Negative 3 pi fourths does have a cosine of negative root 2 over 2. So that's our first theta, is negative 3 pi fourths. The starting location fulfills this criteria. We're good. We're going to move positively. We're going from negative up to this positive value. And as we go around, let's get rid of these just for clarity. And as we go around with the second time we hit a location with this property is here at 3 pi fourths. So theta 2 is going to be positive 3 pi fourths. We keep going. We hit 5 pi fourths. Theta 3 is 5 pi fourths. 5 pi fourths, 6 pi fourths, 7 pi fourths, 8, 9, 10, 11 pi fourths. 12, 13 pi fourths. I forget where we were. 11, 12, 13. We have another rotation to go. 13, 14, 15, 16, 17, 18, 19 pi fourths. 19 pi fourths. And 19 pi fourths, 20, 21 pi fourths. This is one of the reasons we like radian measure, is because you can count as you spin. It's easier than adding 45 each time. That would get really obnoxious. This is obnoxious, but that would get really obnoxious. Okay, so we've got all our thetas. That means we have 7 solutions, right? The problem is that, theta isn't theta, right? We don't care about theta. We want the x values. So for each of these, we have to find the x value, knowing that theta equals x minus 3 pi fourths. So this first one is not theta equals negative 3 pi fourths, but x minus 3 pi fourths equals, you can get Pac-Man on these things, equals negative 3 pi fourths. This is negative 3 pi fourths. Sorry, made you dizzy. Add negative 3 pi fourths to both sides and x equals 0. Right? We got one. That one is that one. Ching! All right, so do the same thing to the next piece. All right, well, x minus 3 pi fourths has to also equal, in theta 2, equals positive 3 pi fourths. If you add 3 pi fourths to both sides, you get 6 pi fourths. Simplifies to 3 pi halves. And there's your x2 for this one. Okay, there's your other x value for that one. For this piece, that's what, 5 pi fourths. So x minus 3 pi fourths should equal 5 pi fourths. Add 3 pi fourths to both sides, and you get 8 pi fourths, otherwise known as 2 pi. So there's your other x value. 3, there's 1, 2, 3. Great. And yeah, keep going, because you're soldiers, you're mathematical soldiers. So I'll do one more, and then we'll cut it. So this, we know that last one is at 3 pi fourths equals 11 pi fourths. Sorry about all the clicking. You add to both sides, and you get 14 pi fourths, and you simplify, and you get 7 pi halves out of it. All right. So let's just check that we're doing it right. So let's get rid of this and this and this, and we should get some of our solutions in here. There's 0, there's 3 pi halves, there's 2 pi, there's 7 pi halves, and we'll have 1, 2, 3 more, 1, 2, 3 more. Once you'll start to see a pattern, right? 0 to 2 pi to 4 pi to 6 pi. Once you start seeing the pattern, just follow the pattern. It goes every 2 pi, great. It also goes every, starts at 3 pi halves and adds 4 pi halves each time. Cool. Great. Here's another one you can try if you're interested. It's tangent. It does the same sort of thing, but I want to try to make this a little shorter than it already is. So good luck. I'm glad you hung in there, and I'll see you later.